Hello. We're going to talk about applying the normal distribution using a z-score. A z-score is useful when the standard deviation is not exactly plus or minus 1 standard deviations, plus or minus 2 standard deviations, and plus or minus 3 standard deviations. I think today's date, Monday, January 14th. Okay, make sure you put your date there. All right. Okay, so when the value of the standard deviation isn't exactly these numbers, okay, we need what's called a z-score. Okay, so goals. Define and identify characteristics of a standard normal distribution. Identify why a standard normal distribution is used. So notice the word standard is the new adjective. Note number 1. To compare data points from different samples, we use a type of normal distribution called a standard normal distribution. Now, that is true, okay? We also use this normal distribution that's standardized. Standard when we don't have exactly the values of plus or minus 1, plus or minus 2, plus or minus 3 standard deviations, right? Those are integers, okay, as opposed to decimals, okay? So a standard normal distribution will have a mean, which is the average of 0, okay? So that's basically the middle, okay? And a standard deviation of 1. Therefore, a standard normal distribution always uses the notation x for any data point is approximated by the standard normal distribution of a mean that's 0 with a variance of 1 squared. Okay, so this is read that some random variable x is normally distributed with a mean of 0 and a standard deviation squared equal to 1 squared. Now, if I say the standard deviation squared, when the standard deviation is squared, that's equal to the variance. Okay? All right, so I could replace this phrase with the word variance. To find where a specific value x, little x because it's specific as opposed to a large x which it represents any possible number, okay, lies on the normal distribution curve, we use the formula x is equal to the mean plus the value of z times the standard deviation. And then I've defined all of those terms, right? So x is a specific value or data point. X with a bar is the mean. Z is the z-score. And sigma is the standard deviation symbol. Okay, so this formula is to find x. We're going to use that formula. Okay? But sometimes we already know what the data point is. Okay? We can reorganize this formula like we did in grade 9, solving for another variable, where we put the other variable that we want to solve for on its very own side. Typically, it's us wanting to know what the z is, right? So that's like the multiplier. Okay, so this is like, where we had y equals mx plus b. So this is y equals mx plus b, where mx is the z sigma. Okay, if you don't understand what I just said, don't worry about it. Okay, so if I want to find z, we want to reorganize and solve for z. Okay, so we want to reorganize that. So it means that I have to move this value over. So I subtract the mean on both sides. Okay, so I have x minus the mean is equal to z times the standard deviation. And then because I'm wanting to solve for z, okay, I divide both sides by sigma. Okay, and then what that gives me is a formula I'm going to use down here. So given that the mean is 68 inches and the standard deviation is 2 inches, we're going to find the z-score if x is equal to 72. Okay, so if I want to find the z-score, I'm going to take this, okay, and I'm going to, see, I can cancel these out. So then I'm going to use z is equal to x minus the mean divided by the standard deviation. So if you looked up in Google or Safari, whatever your search engine is, it doesn't really matter. This would be the formula for the z-score, okay? So I want to find the z-score if x is 72. So I'm going to sub in x is 72 inches. I already know the mean of 68 inches, and I know that the standard deviation is 2 inches. It's just like a formula from grade 9, 10, and 11. Okay, so z is equal to x, where that's 72, minus the mean, which is 68, and the standard deviation is 2. Okay, so we get 72 minus 68. Oh my goodness. Okay. Okay, so that's 4 over 2. So the z is equal to 2. What does that mean? It means that I have two groups that multiply to the standard deviation that gives me a value of this z-score of 72. Does that make any sense? Well, let's look. If I have a mean of 68, okay, and my z-score is 2, okay, what is my score supposed to be? 72. So this diagram matches the example. I'm given a mean of 62 inches. I have a standard deviation of 2. That just means how far apart are each standard deviations, well, they're 2 apart. What would my z-score have to be if I had a data point of 72? Well, it would have to be 2. All right. Now, if you understand that, you might be able to do this question even without the formula, but let's use the formula because that's the point of the exercise. So find the z-score if x is 62. Well, we already know that the values in the example introduction apply to question B, okay? So if we want to find the z-score, we're going to use the z is equal to x minus the mean over the standard deviation by subbing in the data point of 62 inches, the mean of 68, and the standard deviation of 2 inches. Okay? So really, Z is just how many groups is the data point away from my mean. Okay? So Z equals how many groups of the standard deviation is my data point from the mean. Everything focuses on the mean. Okay, so you might say, okay, well, if that's my mean there and 62 is here, how many how many groups of my standard deviation am I away? Well, that's one group, that's two groups, that's three groups. So I should get a value of z equals -3, right? That's where I'm heading. Okay, so let's see. So z is equal to x, where 62 is x, minus the mean of 68, divided by the standard deviation of 2. Z is equal to -3. So that means that z is -3 groups away from my mean. Okay, now it's your turn to try 186 numbers 1 and 2.